Hey everybody, Norm Bauer here with Travel Younger. I am in Ecuador outside the city of Quito, and what you're looking at right here is the actual latitude line between the northern and the southern hemisphere. There's actually two different monuments down here. There's the real one, which this is, and then there's one about a few hundred yards down the road, which was mistakenly identified before they had the scientific equipment to be able to do that. So what's interesting, I'm walking along and they have various different displays here. They have different forms of sundials. This is a particularly interesting little thing because this is what allowed them to know what seasons to plant, what seasons to harvest, what seasons to do this. So right now, as you can see, we are in this quadrant right here, which indicates summer. So I didn't realize this, but the sundials were not just used to tell time, but they were also used to indicate the seasons of the year for agricultural purposes. Down here, we have another little sundial, and based on this, you can see there's an 11 down there, and that's because it's 11 a.m. Now this sundial will move around, of course, and then on the equinoxes it will be equally distant between both. And here's what's particularly interesting too, is that the sun right now is not directly overhead because we are not part of the equinox. And on the other side, it's in total shadow. So what's going to happen is after September, this side is going to be the one that you're going to use to reference exactly what's going on as far as the time of the year. So here's another sign that says latitude 00. That's my lovely guide. Lovely guide, would you like to say hello?
Hello.
Okay.
Hello,
I was asking him about why Ecuador is, out of all the different countries in the world, why is Ecuador so known for being equatorial between the northern and southern? And it's because of the elevations, because of the altitude. Right now we are at about 9,000 feet. We're at about 9,000 feet, and I'm kind of getting used to 9,000 feet. And Chimborazo, which is the volcano not very far from here, is actually the tallest mountain in the world when measured from the center of the Earth. Taller by about 1,800 meters taller than Everest. And now we're going to get into the thing that everyone's curious about, including me. It's the Coriolis effect. And in the northern hemisphere, of course, when we flush the toilet or when we put water down the sink, it goes clockwise. And in the southern hemisphere, it goes counterclockwise. And my guide was explaining to me that hurricanes in the northern hemisphere will go the same way. And what's interesting is if we look at the globe, there is a band right here that has no hurricanes at all because they offset each other. So it seems like the hurricanes start a certain number of degrees south and a certain number of degrees north. So I'm going to go ahead and
One,
continue.
2, and 3.
Okay, back with you here. So what's interesting is the water is just going down. It's not swirling. And if I was on this side, it would swirl in one direction, and if I was on the other side, it would flare in the other side. Okay, now this is going to be interesting because we're only, as you can see, maybe 12 feet away. And just that 12 feet makes a difference. Look at that. It's going in a clockwise direction. That is quite fascinating. So just these little 10 or 12 feet is just making enough of a difference in the gravity to be able to do that.
Okay.
And I guess we're going to go the other direction, right?
Uh-huh.
Okay, how did I know that? So if you remember, that was going clockwise, and this one here.
There we go. In the northern part of the year, the other disasters, speeding but in the other way.
Okay, there it's going the other direction. That's very cool. I want to do one more right along the center.
There we go.
So we're going to do one more. We are right along the equatorial line. So look at that, guys. The leaves don't go in any direction at all. They just go straight down. And again, we were only over there, and we were only over there. So it shows you how specific the gravitational force is just by stepping over the line by a few feet.